Hello everyone. This is our fourth and last lecture for Chapter 8, An Introduction to Hypothesis Testing. In this lecture video, we will go over decision errors and power. Because the hypothesis test relies on sample data, and because sample data are not completely reliable, there is always the risk that misleading data will cause the hypothesis test to reach a wrong conclusion. Hypothesis testing is an inferential process. It uses limited information to reach general conclusions. Sample data are used to draw conclusions about a population. There is always some probability of error in the results. Two types of errors are possible: type 1 errors and type 2 errors. Type 1 error is the probability of rejecting the null hypothesis when it is in fact true. Type 1 errors occur when the sample data appear to show an effect when in fact there is no effect or difference. In this case, the researcher will reject the null hypothesis and falsely conclude that there is a difference or effect. The researcher rejects a null hypothesis that is actually true. Type 1 errors are caused by unusual, unrepresentative samples. Just by chance, the researcher selects an extreme sample with the result that the sample falls in the rejection region, even though there was no actual effect or difference. The probability of making a type 1 error is equal to alpha. Type 1 errors are also known as false positives. Examples of type 1 errors happen in the medical world when someone gets the results from their biopsies and they're told they have cancer, but they really do not have cancer. Or drug testing. Someone fails their drug test when in fact they should have passed it because they are drug-free. Someone is convicted of a crime they never committed. Type 2 error is the probability of not rejecting the null when it is in fact false. Type 2 errors occur when the sample does not appear to show an effect or difference when in fact there is a true effect or difference. In this case, the researcher will fail to reject the null hypothesis and falsely conclude that there is no difference or effect. The hypothesis test failed to detect a real effect or difference. Type 2 errors are commonly the result of a very small effect. Even though there really is a difference, it is not large enough to show up in a research study. There is an inverse relationship between type 1 and type 2 errors. The probability of type 2 errors increase as the probability of type 1 errors decrease. The probability of a type 2 error equals beta. Type 2 errors are also known as false negatives. Examples of type 2 errors happen in the medical world. Someone goes to the hospital and they are sent home when they should have been admitted to the hospital. The test did not find the bigger problem. Or lie detector testing. Someone passes the lie detector test when in fact they should have failed it because they are lying through their teeth. Someone is acquitted for a crime they actually committed. Here's the table of decision errors, or what we fondly refer to the confusion matrix, because it tends to confuse students. This table shows that there are 4 decisions we could make. 2 decisions are errors, so type 1 error, type 2 error, and 2 of them are correct decisions. What we will be focusing on next is power, which is the probability of correctly rejecting a false null hypothesis. Power is the probability of detecting an effect that truly exists. Power is equal to not making a type 2 error, or 1 minus beta. There are a number of factors that affect power, or the probability of correctly rejecting the null hypothesis. So let's take a look at what factors increase power. Increasing sample size n decreases our standard error, increases the test statistic, increases the likelihood of rejecting the null, which will increase power, and vice versa. Decreasing sample size decreases likelihood of rejecting the null, which will decrease power. Increasing alpha increases the rejection area, which increases likelihood of rejecting the null, which will increase power, and vice versa. Increasing mean differences between sample mean and population mean increases the test statistic, which increases the likelihood of rejecting the null, which will increase power, and vice versa. Increasing effect size increases power, and vice versa. Decreasing standard deviation sigma decreases standard error, which increases the test statistic, which increases the likelihood of rejecting the null, which will increase power, and vice versa. Conducting a one-tailed or directional hypothesis test increases the rejection area, which increases the likelihood of rejecting the null, which will increase power, and vice versa. A two-tailed test decreases the rejection area, which decreases the likelihood of rejecting the null, which will decrease power. This leads us into the factors that affect hypothesis testing, which are related to power. Increasing sample size n decreases the standard error, increases the test statistic, increases the likelihood of rejecting the null, and vice versa. Increasing mean differences between sample mean and population mean increases the test statistic, which increases the likelihood of rejecting the null, and vice versa. Decreasing the standard deviation sigma decreases standard error, increases the test statistic, which increases the likelihood of rejecting the null, and vice versa. One last thing we need to talk about is the assumptions for hypothesis testing. In order to conduct what we call parametric hypothesis tests, we must meet three assumptions. 1. Random sampling. We assume that data were obtained from a random sample. 2. Independence. We assume that each outcome or observation is independent. One outcome or observation has no effect on another. And 3. Normality. We assume that data in the population are normally distributed, especially for samples of n less than 30. In larger samples where n is greater than 30, this assumption is not as critical. Remember, due to the central limit theorem. This concludes our coverage of Chapter 8. I will post one more video that will show you how to conduct hypothesis tests, both directional and non-directional. This video will also show you how to write appropriate APA conclusions.